So we have this term, multitasking. So multitasking is like whenever we are executing the multiple tasks at the same time. That is multitasking. Then we have two types of multitasking: process-based multitasking and thread-based multitasking. Process-based multitasking is like whenever we are running multiple processes at the same time. Processes are like a big process. Let's say you are running Chrome, that is a one process. You are running VS Code, that is second process. You are running any other application, that is third process. So whenever we are running many programs in a machine, in an operating system, that is known as process-based multitasking. So executing multiple tasks at the same time, where each task is a separate independent program, or we can say process, is called process-based multitasking. It is suitable for operating system level. It is like whenever we are running multiple programs together, like whenever, let's say you are running Chrome as a browser, you are running Python, you are running Firefox, and so on. So whenever we are running multiple softwares in a machine, that is known as process-based multitasking. Then with thread-based multitasking, it is like whenever we are running one process, but inside one process, we have multiple threads. That is known as thread-based multitasking. So executing multiple tasks at the same time, which each task is a separate independent part of the same process, is known as thread-based multitasking. For example, let's say we are running Chrome browser. Inside Chrome browser, we are running many other processes. That is thread-based multitasking. So what are threads? Threads are the separate flow of execution in a program. Okay, let's say we have this process here, a big process. Let's say we call it Chrome. It is a Chrome browser. Let's say we are running Chrome browser. Inside Chrome browser, we have multiple threads are running, multiple threads. Now these threads follow this different task. Okay, let's say this is thread number one, thread number two, thread number three, thread number four, and so on, thread number five and thread number six. So this particular Chrome has multiple threads. Okay, so threads are like the process of a one single program. So this is one thread, second thread, and third thread, and so on. Each and every thread has its own particular task, but they are the part of the same process. That is known as thread-based multitasking. So executing multiple tasks at the same time, where each task, means each thread, is a separate independent part of the same program. Means these are separate thread. This is one thread, second thread, third thread. These are like different threads, but of the same process. Process number A. These are the part of the same process, process number A. But they are separate threads and they have separate tasks. Okay, that is known as threading. So whenever we are running multiple threads together, that is known as thread-based multitasking. And each independent part is known as thread. It is suitable for programmatic level like MS Word or any application. Let's say we are running any kind of application. Inside any application, we have multiple threads are running. So processes are made up of threads. We have thread number one, we have thread number second, thread number three. So all together made up one process. So this is one process. Why using three threads, we are making one process. And each and every thread has its own task. Okay, secondly, each task are independent with each other. Okay, means two tasks are not dependent on each other. Okay, that are known as threads. Is it clear? What are threads?
Yes, teacher.
Okay.
Process.
So thread is a separate flow of execution. Every thread has a task. Multi-threading is like whenever we are running multiple threads in a program or process. Threading is like then you're threading. Threading module. Threading is a module which is used for creating, controlling, and managing threads in Python. So we have threads and how we can make our own threads by using threading. Threading is a module in Python. And with the help of threading, we can create our own uh, programs, like we can create our own threads, we can control them, and we can manage them. Then we have this main thread. So in the Python, we have this concept of main thread. Main thread is like whenever you are running Python, inside Python, you are running any kind of program, any kind of program. So whenever you are running any program in Python, so that Python will create a thread, and that thread is known as main thread. For example, let's say in Python, if you run this part, let's say print hello world. If you are running print hello world, so even for this particular line, we have a separate thread, and that thread is known as main thread. And who is responsible for creating main thread? This Python PVM. PVM means Python virtual machine. So when we start any Python program, like any program, whether it is of single line or whether it is of multiple lines, one thread begins run immediately, which is known as main thread of that program created by Python virtual machine. The main thread is created automatically when your program is started. Okay, so how we can see the main thread? So this is a code. So what we can do, we can import the threading. Okay. This is a code for running. See, here we have this import threading, and then from the threading, we are running the current thread. So T is a object here, and threading is a class here. So we are creating an object like as a reference variable threading, and then we are getting the current thread of this particular program dot get name. So we are actually getting the name of this current thread, and then we are running this print hello world. So and then print T. So what we are doing is we are getting the name of this current thread, which is responsible for running this print hello world. So if I run this one, you will notice hello world. First, this line, hello world. Second, this main thread. So the name of this thread is main thread. Okay. So whenever you are running any kind of Python program, there's a one thread will run automatically. That is known as main thread. Okay. And whether your code is one line or whether your code is of multiple lines, Python virtual machine, which is PVM, will create a thread that is known as main thread for your program. Okay. For example, here we are running hello world. So for this hello world, we are running, the Python is creating a main thread, and we are getting the name of that main thread with the help of this line of code. We are importing threading. Threading is a model here. Okay. For creating, managing, and controlling threads. Then we get this threading dot. We are getting the current thread of get name. We are getting the name of the current thread, which is created by the Python virtual machine. And when I run this one, you will notice this is the main thread. This is the main thread. Okay. So this is how we can get the name of the main thread.
Teacher, question. So in
Yes.
the output, how do you, where's that command that you get the, how come do you get the main thread? Where's that? Is it because of the get name or the current thread?
Both. This one up to here. This is the command C. With the help of this
Okay.
command, we are actually storing the main thread in
Mm,
the variable T.
T.
And then
Okay,
we are
because of
printing T
print
here.
T. Okay.
So
Okay.
we are saying Python that please get the name of the current thread. Okay, with the help of threading module. That's
Okay.
it.
Okay. Thank you, teacher.
So this another module which is known as queue. It is a primarily used to manage to process large amounts of data on multiple threads. Now, what are queue? Queue are like a data structures. And what are data structures? Data structures are like a, we can say, data structures are like a structure, like how we are storing the data in the particular program. So data structures are like how we are storing the data, how we are managing the data. That's it. It is a way of storing data. For example, let's say you have a almirah, let's say you have any almirah in your house, any cupboard. So in that almirah, you are just putting your clothes. Okay, so you have a way of putting your clothes. Like you are putting your some cloth here, some clothes here, and some clothes here. Let's say shoes here. So this one is an almirah. So here this almirah is our data structure. Okay, this almirah is our data structure, and the clothes are the data there. These clothes are data. So data structures are like a way of storing data in your machine. Now, how you are storing data, that really matters a lot in the industry. Okay, like how you're storing your data, how your data is processing. Okay, for example, let's say let's say if you don't have any almirah, then your clothes will be everywhere. Okay, your clothes will be spread everywhere. So that is why if you have any almirah, then you will put your clothes in a structured manner. First, yeah, your first pair of clothes, then second, and then your shoes, and so on. So in the with the help of this almirah, you are putting your clothes in a structured manner. Same as this almirah is like a data structure. In the data structure, you are putting your data in a structured manner. So that in the next time, whenever you wanted to fetch anything from your almirah, then you can fetch easily. Okay, you will not take any amount of time to search for any clothes. Okay, so same as the data structure, whenever we are storing data in the data structures, we are just reducing the time of accessing the data from the data structure. Okay, like let's say we are storing the data in the data structure. So it is like we don't need to search for that particular data a lot. Secondly, it will reduce the time and it will reduce the space complexity. Okay, so that is like a example. Okay, so we are not going to study data structure, but yeah, data queue. Queue is the part of the data structure only. In the queue, what is queue here? Queue follow a syntax that is FIFO. FIFO means first in, first out, like this. Let's say you're putting a data first. One data, let's say data one. Then that data should be out first. Okay, data one out. Then you are putting second data. Then that data should be out first. Secondly, okay. For example, let's say we have a queue of line. Let's say this is a hall. Okay, in your let's say in any theater, there's a picture hall, movie hall. Okay, in this we have a line of the people. Okay, let's say this is one person. This is second person. Okay, and so on. This is third person. This is fourth person, fifth person, and so on. So we have a line of all the people in the hall, in outside of the hall. Let's say this person is going first, and this is the entrance, and this is the exit. Okay, this person is going first, then this person will also go out first. Then this person is going second, and this person will go out in the second. This person is going third, and this person will go out in the third line, in the third number, and so on. So there's a concept of first in and first out, second in, second out. Like whichever person is coming first, that person will go out first. That is a concept of queue here. Okay, we will not going in detail with in the queue because queue is a kind of a very large topic of data structure, but it follows this topic first in, first out. Rest we will see in the coding part. Okay. So there's a difference in the threading process. So let's discuss what are threads and what are process. Process means any program is in execution. Whenever we are running any program, like as a whole, let's say Chrome is a one process. Okay. Firefox is a one process, etc. Then thread means a segment of a process, which means thread is a part of any particular process. The process takes more time to terminate. So whenever you wanted to close Chrome, so Chrome will take large time to close as compared to the process. Sorry, as compared to the thread. Thread takes less time to terminate because thread is a very small part of a large process. That is why. And process is made up of threads only. So then it takes more time for creation. It takes less time for creation. It takes more time for context switching. It takes less time for context switching. Like let's say you wanted to switch any tab in the Chrome. We wanted to switch anything, then process will take more time than the threads. The process is less efficient in terms of communication. Threads is more efficient in terms of communication. Let's say you wanted to communicate one browser with any other browser. Sometimes it is not possible even. But for the threads, we can communicate two threads together. So that is why communication between the processes is not efficient, while communication between the threads are efficient. Then multi-programming holds the concepts of multi-process. Like multi-programming is like whenever we are running multiple applications in a machine. So that is multitasking. Here we don't need multiple programs in action for multiple threads because a single process consists of multiple threads. A one process is made up of multiple threads. So we don't need multiple programs for multitasking. If we have a one program, then we have multitasking in terms of threads because inside a program we have multiple threads running. But in the process, we have to run multiple programs. Then we can say it is a multitasking, right? So in the threads, if we are running one program, then we are multitasking. But in the process, we have to run multiple programs. Then we can say it is a multitasking. Okay. The process is isolated like a separate thread shared memory. In the threads, like for example, let's say we have one process, Chrome. Second process, VS Code. Third process, any other program. So these are programs. These are separate programs. These programs are not dependent on each other, right? So that is why these are separate programs. So and but threads, let's say we have this one program. Inside one program, we have multiple threads running. And each and every thread shared the memory of the same program because this is Chrome browser. For running Chrome browser, we need multiple threads. So each and every thread shared their own memory, like share the memory with each other because they are the part of the same process. And for running the one process, we need multiple threads working together. Okay. The process is called a heavyweight process because the process is like a heavyweight. It is a one program. Chrome is a heavy software and threads are the lightweight as each thread is a process of shares code, data, and sources. So a thread is a lightweight because a thread is running inside a process, and the threads can share their memory, share their data, share their resources. Why? Because they are the part of the one single process. Then process switching uses an interface in operating system because whenever we wanted to switch between the process, let's say I wanted to switch to Chrome browser. So I will use Chrome browser here, right? So it needs some memory. It needs operating system for switching between the programs. But thread switching is does not require calling any operating system and causes an interrupt to the kernel. So for the threads, we don't need any calling because calling is automatically inside any process. And we don't need any operating system for that. It is automatic. Then if one process is blocked, then it will not affect the execution of the other process. For example, let's say if you block Chrome, then that Chrome will not affect any other program in your machine. Let's say Python. So Chrome will not affect Python. Python will not affect Chrome. Let's say Python is not working in your machine. Okay, so Python will not affect the Chrome browser. But in the threads, if one thread is not working or if one thread is blocked, then we cannot say that we cannot run the other thread. Okay, that is a specific scenario we will discuss. Then changes to the parent process do not affect the child process. It is like process is a separate entity. Chrome browser. Let's say Chrome browser is a separate entity. Chrome browser do not have any parent, do not have any child, but thread have many parent. For example, Chrome. Chrome is a parent of multiple threads. Chrome is a parent of multiple threads. So if we are changing the Chrome, then we are changing the process of the threads also. So threads are dependent on the process, on the program. Okay, that is why thread is dependent on their parent class. A system call is involved in it. No system call is involved. It is created using APIs. Okay, which is we don't need any specific call for any thread, but we need a system call. Like when you double click on any particular browser, then you are running it. That is a system call. But we don't need any system call in the threads. Then the process does not share the data with each other. Here, threads share the data with each other because now your Python is not sharing any data with the Chrome browser. Same as the threads share data with each other because threads are the part of the one single process. So they need to share the data. They need to share their memory. So that is like the big difference between the process and the threads. Okay. Then threads sometimes called lightweight memory, which is process, and they do not require much memory overhead. They are cheaper than processes. A thread has a beginning, an execution sequence, and a conclusion. So this is like a process of thread. We create thread, thread will work, and then thread will terminate. That is a process. Okay, now how we can create threads? So just give me a sec. Okay. So how we can create threads in the Python. So for creating a thread, we need threading class. Okay, like we need threading module. So we can create threads by three following ways. First, we can create threads without using a class. Then we can create thread by creating a child class to thread class. Thread class will be a parent class here. Then creating a thread without creating child class to a thread class. Okay, so let's see these three mechanisms. Okay, this code is for printing. This one is for printing the name of the current thread. Okay, then we have this one, creating a thread without using a class. So I have already coded. Okay, so let's see how we can create a thread without without using a class. So here you can see we are not using any kind of class. First, we are importing thread from the threading library. Okay, threading module, we are importing thread. So then this is my function. This is my simple function without any arguments. Okay, we don't have any argument here. So we have this def and this here. This is my function name here. And this will print thread running. Okay, then what we are doing is we are creating an object. And here we have this thread. Thread is again like a function here inside this particular class. And then inside this thread, you will notice a target. What is my target here? This function. So actually we are calling this function, this with the help of this thread here. And then we are starting a thread. What is starting? In the thread, we have multiple functions. Starting is one of them. Starting is like whenever we are starting any thread. This is for starting the thread. Okay, this is for starting the thread. And here we are calling the display function, this function inside the thread. So inside my thread, this function will be executed. If I run this one, you will notice, see, thread running, this line. Nothing is different here. We are printing just the line here, but how we are printing? We are printing with the help of thread here. So how we print a normal function? How we print a normal function? We have a function here like this one, def function. Okay, and then we let's say print anything here. Okay, let's say hello. And then we actually call the function, right? We actually call the function. But this is like normal calling. But here, we have this function. We are creating a function here. This is a normal function. How we are calling is different here. We have this thread here. Inside thread, we have this target equal display. Okay, this means display. And then here we are starting the process. This means we are calling this function inside a target, inside the thread. And then we are starting this thread. which thread we are starting? We are starting this particular function. That is without arguments. If you wanted to call with arguments, then you can use this one. This is with arguments, where we are taking one argument from the function. Okay. And then we are printing thread running and the value of the argument. And then again, we are creating a class. Sorry, we are creating a reference variable T equal thread. Inside thread, we have this one, which is target equal. This again, we are calling this function. And then arguments. Arg means argument. Inside this argument, we are taking one argument because we have one A here. So this is the parameter. Okay, this is the argument A, and the value of this argument is this one, 10. Let's say we have multiple arguments B. So here we will put other number 20, comma, like this one. Here we will put 20 as well. Sorry, B as well. So these are arguments, and we are providing the value of the arguments here in the args here. And then we are running the thread T dot start. Otherwise, how we create a function with the argument? We have this A, comma B, and then we print actually A, comma B, and we are providing values to A, comma B here whenever we are calling the function. But here in the threading, we are providing the values in the argument session. So if I run this one, you will notice 10, 20 with this AB. Okay, thread running and 10 and 20. Is it clear this much? How we are running a thread?
Yes, teacher, clear.
Then, how we can run a thread with the help of for loop? Okay, see. First, this one you will notice. Here with this function here, disappear. In this function, again, we are taking a different function. Okay, a simple function. In this function, you will notice that for I in range, we are running this particular, we are running this loop 5 times. Okay, and here with this thread object, okay, T here, and then here with this target, displays my function here, taking 2 arguments, which means we are running the function, this function, display function 5 times. Okay, display function 5 times. Why 5 times? Because it is inside the loop. Inside the loop. And then we are starting the process. Okay, so if I run this one, you will notice 5 times thread running. But if you notice anything, the numbers are moving like this one. Like here, if you notice, if I start again, see, these are not in the sequence. This is in the sequence. But if I run this again, so if I run this one more time, and then one more time, see, if I run this again, sometimes they are not in sequence. Okay, let's say, see here you can see these are not in sequence. Why? Because every thread is running independently. Every thread is running independently, like all together. So this is like this thread is running, then this thread is running, and then you can see thread running 10. Here we are not printing 20 here because these are like individual values. They are running all together. So whenever the threads are running together, they will cause a mess here. Now you can see we don't have any sequence here. Sometimes we have sequence, sometimes we don't have any sequence. So that is a disadvantage of thread. Whenever you run multiple threads together, they do not follow any sequence. They all together run all together without any sequence. Okay, so that is a disadvantage. Let me show you a difference. This is our thread with the help of for loop. See this example, you will see this example here. In this, we have this comparison between the multi-threading and the simple process. See, this is our simple threading. Okay, this is threading and this is simple about for loop. Okay, so if I show you the comparison between the for loop and this function, see, if I run this one, see, here we are running, what is happening here is, first we are running this child thread, and then we are running this main thread. Now these are threads. These will run all together. There's no sequence in this particular thing. We are running one thread and we are running second thread. Okay, one thread and two thread. These are running all together. There's no sequence. That is why you can see in the normal Python program, first this will need to be executed and then this one. But whenever you are using thread, there's no sequence here. You will see first we are running child thread, and then in the middle of the child thread, we are having the main thread. Then we are having main thread, and then we have this child thread. So there's no sequence here. There's no sequence because all threads, like two threads, are running together and they will follow no sequence. Okay, because they are using multitasking concept here. Multitasking, like whenever two threads are running together. So there's no concept here. So that is why you can see we have this child thread and we have this main thread. And if I run this again, you will see again they are following a different syntax. See, then with this child thread, then main thread, then main thread, then in the middle we have this child thread and then main thread. So there's no sequence here. Because whenever we are running program, we want sequence. First, child thread should be run, then main thread should be run. But you can see there's no sequence. So that is a disadvantage of a thread, that there's no sequence. All threads are running together because all threads are independent here. No one is following no one. So all threads are dependent. Sorry, independent. So they are not following anyone. So they are running by their will. Okay. So that is an example of a child thread versus main thread. Same as this function is also a like function. See, this is a simple function. This is a function without threads, and this is a function with threads. So if you run this function without threads, this function and this for loop, you will see this will run in line. See, this is running in the sequence. First, we are running this function 5 times. So you can see this line 5 times here. These are in sequence. And then you can see this main task in sequence here. So this is a sequence. But when you see previously, there's no sequence here. There's no sequence here. So in the threads, there's no sequence, but in the simple programs, we have the sequence. But simple programs are slower than the threads. Okay, so this is a comparison between a simple process and a threading here. Whenever you are running multiple threads, then you are running all together. There's no sequence here. But whenever you are running any process without threads, then they will follow a particular sequence. Okay, is it clear this much? Any questions?
No, teacher.
Okay, so this is one option, which is creating a thread without using a class. Second option is creating a thread by creating a child class to the thread class. Here we can create a thread class by using a child class. For example, here we are importing threading. In this, you can see a class here. The class name is myThread. And this myThread is a child class because this class is inherits from the parent class thread. Thread is this class, okay, which we are importing from the threading here. So myThread, okay, myThread is a child class of the parent class thread, this thread. And then we are writing nothing here, which is pass. You can write anything. But if you print the name of this thread, you can print the name by using t.name. And if you run this name here, you will notice thread number 1. So this is the name of my class. My class name is thread number 1. Basically, my class name is myThread, and we are running this myThread with the help of parent class. And when you are printing, see, myThread is a class here, which is we are creating a reference variable, a object of t, and then we are printing t.name. Name will print the name of my current thread. And what is the name of the current thread? MyThread, thread number 1. So this is printing thread number 1. Okay, thread number 1, which means this is the part of this thread, this parent thread. Now inside this class, you can write anything. You can execute any kind of program. For example, let's say we have this one start method. In the threading, we have methods like, let me show you. In the threading, we have methods like this one, start, run, join. We have 3 methods. In the start, once a thread is created, it should be start by calling a start method. So whenever you are creating a thread, then you are actually starting, you have to start the thread. So how you are starting? Using start method. We have to call the start method. Just like here. Whenever you are creating a thread, starting is important here. Okay, for example, here we are creating my class, my thread, And then we have this thread method. In this thread method, we have this def run. Inside class, we have this function here. Okay, this function here. Okay, and then we are running this. We are creating an object, and then we are starting. So this will run method. Okay, run method. See, and this particular class, this will override the thread module run method. Okay, like this class is running. This class is running this particular function, and this particular function is printing this line, which is run method. And then we are storing this class my thread inside object, and then we're starting the object by using start. Okay, so this is a kind of a child class of a main class. Otherwise, if you see the main class, main thread, in the main thread, if you notice here, we are creating a function and we are calling the thread with the help of thread here. Thread is a parent class here. Okay, so this is a program without creating a class. But here we are creating a class here. We're creating a class here. And in this class, we are actually calling my thread class. This can be any name. And then we are using this my thread as a child thread here. Okay, child thread. And then we're starting the child thread with the help of the parent thread. Okay, that is a procedure here. Then we have this join method. Join method will see. This is a join method. This method is used to wait until the thread completed execute the run method. So we have this run method. Every thread will run this method when thread is started. We can override this method. We can use our own code as a body of the method. Our thread will terminate automatically when it comes to the run method. Run method is like whenever we are running one method, one thread, then one thread will complete, then we are running the second thread, and then third thread. These are like providing a sequence because when we are using a threading, thread will not follow a sequence. So we want if we wanted to establish a sequence, then we can use join here and run here. Run will run one thread at a time, and join will start a new thread when one thread will execute completely. That is a join and run. So if I show you, see the join method in the practical. In the join method, you will see class my thread here. Okay, this is a simple thread. We have simple class. Inside this class, we have a function, and this function is printing child thread. Okay, this function is run five times, five times, and then we're creating a class. Okay, sorry, creating an object, and then we are starting the object. And then you can see we have this join here. What join will do? Join will first run this child class, and then it will run the main thread. So we have two threads here. First thread, the child thread, and second thread, the main thread, the Python thread. Okay, which is this thread is created by Python virtual machine automatically. Okay, so and this is the main thread here. So this is the child class and this is main thread. So what were happening before? Before these programs are running all together without any sequence. But in this particular program, they will follow a sequence because we are using a join here. What join will do? Join will first run a one thread and then it will run the second thread. If I run this one, you will notice first we are running the child thread and then we are running the main thread. So they are in sequence. But if I remove this join here, then you will see there's no sequence at all. See, if I run this again, see, there's no sequence. First, we have this child thread. Then in the middle of child thread, we have this main thread. Then in the middle of this main thread, we have this child thread. So there is no sequence here. But when I use a join method here, you will see a sequence here. If I run this one, you will see a sequence. First, we are having this child thread properly, and then the main thread. So that is a sequence. So that is why we are using join here. Join will first execute one thread and then it will execute another thread. Is it clear? This much?
Yes, teacher, clear.
Okay. Then third mechanism of creating a thread is by using creating a thread without creating a child class to a thread class. Third mechanism, which is this one. Here we are creating our own thread. How? See. First thing is this one. Here we have this class my thread. This is my parent class. Okay. My thread is my child class and thread is my parent class. Here, if you notice here, this part, this particular part, this one. This line will throw the error. Why? See, whenever you are starting any thread, so threads are not callable. Like we cannot call the thread as it is. That is why it is not callable. So whenever you see this program thread underscore init, what is this one? Initialization. So whenever you are initializing any thread, means you are calling the thread because init will run automatically. So whenever you are running the thread automatically, like while calling them, then you will see this will throw the error because threads are not callable here. Directly, they are not callable. But if you run this line inside a class, then they are callable. See, we are creating the class my thread, and here we have this thread here. Inside thread, we have this function here and the second function here. This function will run automatically without calling it because here we are using init here, a magic function, which will run automatically. And then second function is run function. So here we are storing again, we are starting the thread and we are running the main thread. So first, this line will be printed and then main thread will be printed. If I show you, see this one, if I run this one, see there's an error here. Why? Because threads are not callable here. This thread, we are calling this, actually we are calling the main thread here. These are not callable. Okay, these are not callable. How we can call them? So there's another mechanism, this mechanism. See, here we are creating a class. Okay, we are again creating a thread. Then here, if you call any kind of parent thread, then you have to name the thread here, thread dot underscore init. You have to call them inside a class. Threads individually are not callable. You have to call any thread inside a class. That is why we are calling this parent class, parent thread inside a class. Now this will work. This will run as per the. Okay, we have to save this code and then we can run it. See, now this is working. Okay, now where this line of code is printing and this line of code is printing, which means we can call a thread inside any class, but we cannot call any thread individually. That is not possible. Okay, so that is what I wanted to clear out. Okay, so this is without parameters and this line of code is with parameters. This line of code is with parameter. Here we have this parameter self A. A is a parameter here. Again, we are calling the thread, the main thread by calling thread underscore init. This will run automatically because we are using init function here. Init will run automatically. And then you have this child thread constructor here. This line will be printed with the value of A. And then we have this main thread. And we are providing this value of A here in the while creating object. And if I run this one, you will notice 10 here, the value, the line here, and then main thread. So here the main thing to note is we cannot run a thread directly. Like we cannot call the thread directly. So for calling the thread, we need to call here. We need to name, we have to call the thread inside any class only. That is what I wanted to make clear. Then third method is creating a thread without creating a child class to a thread class. So this is an example, a very simple example. We have this class here, my thread. In this class, we have this function here, a simple function which is taking two parameters, A and B. Then what we are doing, we are creating a my thread. My thread is a simple class. It is a simple class. Okay, it is a simple class and it is not inherits from any other class. It is a simple class. It is not a child class. Okay. Then we are creating an object of this class. Now you can see here, we have this thread here. Now we are calling the thread, the main function here. And then in the target here, in the target, we are providing a my thread, this variable dot this function here, disappear. Okay, so here we are calling this object, and inside this object, we are calling this function here, dot this. And then we are providing a values here, and then we are running it. Okay, so this is third mechanism of creating a thread. So this is, we are not creating any child class, we are not creating any parent class, we are not creating any class. We are just calling the thread directly. Okay, like by creating a thread object here. So we have two objects here, one object and the second object. First object is on my class, and second object is of the thread class, the main class. Okay, and then the target is my t, which is this is my object here dot, and from the object we are calling this function here, and the arguments are here 10, 20. So this is like without creating a child class, we are calling the thread. Okay, so we have three mechanisms of creating a class. Sorry, using a thread. First, we can create a thread without using a class. Second, we can create a thread while using a parent class thread. And third, we can create a thread by like without actually creating a child class. These are the three mechanisms. Then here we have this function here, which will perform single tasking using a thread. What is single tasking? Single tasking is like when one task will execute, then other task will execute again. So that is single tasking. So if we have this program, class my exam. Okay, so what will be the flow of this program? What will be the flow? In this flow, you will see first this line. Here we have this class examination. In this, we have one function, solve question. In this, we will print question number 1, question number 2, and question number 3. And inside this solve question, you will see we are calling three functions. Q1, this function, Q2, second function, Q3, third function. And these function will print question number 1, question number 2, question number 3. Okay, this is a simple class here. Then we are creating my exam as a object here, and then we are calling a thread. Target is my EI, which is my dot solve question. We are calling this function here solve question. This is single tasking. Why it is single tasking? Because we are calling this function. When we call this function will first call this function, which is question number 1, question number 2, and then question number 3. So inside this function we are calling three functions. So if I run this one, you will notice question number 1, question number 2, question number 3. This is single tasking. Why? We are running one function at a time. So this is single tasking. But whenever you wanted to perform multitasking, so this is an example of a multitasking. See, this is the example of multitasking. In this multitasking, so when the multitasking is useful, let's say we have a hotel. In the hotel, we are taking the orders from one person, and then we are taking the like let's say we have this hotel here. Okay, inside a let's say a restaurant. Inside a restaurant, we have many customers here. Okay, many customers. So let's say customer number 1, customer number 2, customer number 3, customer number 4. And let's say there's a waiter here. There's a waiter. So how the waiter will perform? How the waiter will act? It is not possible. See, let's say there's a waiter. If the waiter is performing the single tasking, so how the waiter will perform single tasking here? Waiter will take order from table number 1, table number 2, table number 3, table number 4 first. All the tables. Then waiter will distribute the food to table number 1, table number 2, table number 3, and table number 4. This is how the single tasking will work. So why the single tasking is not beneficial here? Because you will see, let's say you are waiting for your food. So the food will take a very long time to come. Why? Because the waiter is first taking orders from all the members. Let's say there are like 50 tables. 50 tables, 50 members in the restaurant. So the waiter will first take all the order from the 50, all the like orders from the 50 customers, and then will go to the chef. Chef will create the order of the 50 customer, and then a waiter will distribute order one by one. So this will take a very long time. But when the waiter is performing the multitasking, then first waiter will take the order from table number 1 and table number 2, and then will go to the chef. Chef will create the food for the table number 1 and table number 2. Then the waiter will come and distribute food to table number 1, table number 2, and also take the order from table number 3 and table number 4. So you can see this is multitasking. The waiter is taking the order and taking the distributing, serving the food at the same time. So this is a multitasking. So we have many scenarios when we need multitasking than the single tasking. For example, if I run this program, you will see here this hotel here. Hotel is a class here. Inside hotel, we have a T here. Okay, of variable here, which will run automatically. So here you will notice we have this another function food here. This food will run 5 times. Okay, this function will run 5 times. Inside 5 times, we are calling 1, 2, 3, 4, 5s. Like we are calling this function one time and then running the value one time. We are calling this function another time and then we are running this value another time. Okay, means we are also calling this function 5 times because this function, this variable is inside this food variable, and this food function will run 5 times. So here we are creating two objects here. First object is h1, second object is h2. H1 will print taking order from the table number 1. This is my T here. Okay, my T here is this line. Take order from table number 1. Table. Okay, and this is my second T. This is serve order from an order to a table. So we have two variables. Okay, like two objects, which is calling the same class hotel. Inside this hotel, we are running this function 5 times. So this is taking order one time. Uh, in this H1, we have this taking order, and H2 we have serving order. Then here, if you notice, we are creating a thread for T1 and T2, and then we're starting the thread. If you run this program, you will see there's no order here. They are multitasking. H1 and H2, they will run together. Okay, they will run together. If I run this one, you will see. For now, they are running in the sequence, but if I run this again, let me run here. See, here if I run my threads file, okay. Now you can see they are following the order, but if I run this again, they will not follow a particular order. See, now there's no order here. First, we are taking order from table number 1, table number 2, 3, 4, and then we are serving the order to table number 1. Then we are taking the order from the table number 5, and then we are serving the order to table number 2 and 3 and 4 and 5. If I run this again, you will see there's no order here. Now you can see taking order from the table number 1, taking order from table number 2, then serving order to table number 1, then taking order from table number 3, then serving order to table number 2, then taking order from the table number 4, then serving order to table number 3. So you can see there's no sequence here. Why? Because these functions, H1 and H2, they are running together. They are running together. And that process is known as multitasking. Whenever two functions are running together. Is it clear? Multitasking, single tasking. Any
Yes, it,
questions?
no, teacher.
Okay. So in the multitasking, we are running the functions together. In the single tasking, we are running function one by one after another. When one function will execute, then we will run the another function. Then the third function in the single tasking. While in the multitasking, we are running multiple functions all together. We are not waiting for any one function to complete. That is multitasking. So this is an example of multitasking, and this is an example of a single tasking. Then, with the help of this multitasking, we are having one problem, and that problem is known as race condition. What is race condition? See, we have a problem which is a race condition. Race condition is a situation that occurs when threads are acting in an unexpected sequences, thus leading to an unreliable output. This can be eliminated using thread synchronization. Okay, which is like you will notice whenever we are using multitasking, there's no sequence here. As I said, whenever you are performing the multitasking, there's no sequence. Why? Because we are running the threads all together. There's no sequence. So that particular problem is known as race condition. When your threads are running together and you don't have any sequence. In that condition, what we can do? We can use synchronization. Okay, first we will see the race condition. See, this is the code for the race condition. In this code, you will notice first we are importing the threading. From the threading, we are importing the thread and current thread. Okay, we are using the current thread so that we can print the current thread name here. So this is a program. And in this program, what we are doing, it is a flight system program. Okay, it is a, let me write here, it is a flight booking function, a program. In the flight booking program, what will be the flow of the program? First, let's say there's a user one. User one will go to the platform and check for the seats. Check for the seats, whether seats are available or not. If the seats are available, then we can book the tickets. Right. Now let's say user number second will come and user number second will also check for the seats. If seats are available, then we will book the tickets. Let's say there's user number three. Now user number three will check for the tickets again, check for the seats. If seats are available, let's say now seats are not available, then we can write a message, sorry, tickets, or we can say seats not available. Okay, so that is a kind of a function. So here, sequence is very important here. Sequence is very important here. Why? Because if there's no sequence, what will happen? And if there is sequence, what will happen? See, if there is sequence is important here because when the user one will come, he or she will check for the tickets. And if the tickets are available, then we are booking the tickets. Then the user two will come and check for the tickets. If the tickets are available, then we can book. So the sequence are important here. But if there's no sequence, so what will happen? See, I am running this code, then I will explain. So first I will run this code. They're like three users, Bhavya, Aryan, and John. They're like three users. These three users are booking a ticket and only two tickets are available. Okay, two tickets are available. Just two tickets are available. So what will happen when the John will try to book the ticket? So I'm running this code. See, if you notice, two tickets are available. One seat is allotted for Bhavya. Now, how many seats are available? One seat. Because one seat is allotted by me. Then one seat is allotted by another user. Then there's no user. Available seat 0. Then, sorry, all seats is allotted. So when the John wanted to reserve the seat, they will print this message. Sorry, all seats are allocated. This is a sequence. This is a sequence. But when you run this program again, so you will follow, they will show no sequence. See, if I run this again, see, this is a sequence, but now here you will notice available seat 2. One seat is allotted by Bhavya, but again available seat 2. How the seats are available again if one seat is allotted by Bhavya. So this is not a sequence manner. If I run this again, you will see no sequence. Now you can see available seat 2. Okay, again available seat 2. How it can be possible? If I run this again, you can see there's a order here. See. Now there's no again there's no order here. Available seat 2, one seat is allotted. Now how many seats will be remaining? One. But here it is showing 2 again. How is it possible? Then if one seat is available, then how this message will be printed? Okay, if I run this again. Okay, now you can see there's no sequence. Available seat 2, one seat is allotted by Bhavya. Again available seat 2 and available seat 2 two times. And then one seat is allotted for John and one seat is allotted for Aryan. It is not possible because we have two seats only. And two user can like book the tickets. But how 3 person can book the ticket? So here you can notice there's no order at all. There's no order at all here. So that is why this is known as race condition. Race condition is like whenever we have multiple threads are running all together and there's no sequence. If I show you this one, see. From threading, we are importing threads here. This is my class. Inside this class, we are creating a variable, available seats. Okay, this will run automatically. Then we are reserving a seat here. So here we are taking an argument need seat. So first, the program will print how many seats are available. So at first, 2 seats are available. Why? Because here we are providing 2 here. 2 seats are available. Then here we are checking if seats are available. If seats are available, seats are more than the needed seat. Then we are printing the name of the person who is taking the seats. And then we are printing this message that this seat is available or is allotted to this particular person. And then we are decrementing the number of the seat. Why? Because if one seat is allotted, we can decrement to 1. And then if one seat is again allotted, then how many seats are remaining? 0. So basically, we are decrementing the seat here. And if no seats are available, then we can print this message, sorry, all seats are allocated. So this is a simple program. Then we are creating a thread. We are creating a flight class. Flight is my class here, which will take one argument, available seat. So seats are 2 here, and this is the object here. Then we are creating 3 threads here. You can see 3 threads. 3 threads, one thread, second thread, and third thread. One thread for one person, second thread for second person, and third thread for third person. How many seats are available? 2 seats. So one seat is allocated for me, second seat is allocated for another person, and third seat is not available for the John. Because how many seats are there? 2 seats. And then we are running this thread all together, T1, T2, and T3. So these all 3 threads will run together. That is why if these 3 threads are running together, we have no sequence. We have no sequence. All threads will run simultaneously without worrying about any other program or any other thread. So this is known as race condition, when all threads are running together and there's no sequence in the program. Here we are achieving the multitasking, but the problem is the program is not in sequence. Okay, that is known as race condition. Is it clear, the race condition?
Yes, teacher.
Now, how we can overcome with this race condition? The solution is thread synchronization. What is thread synchronization? Thread synchronization is whenever we are locking the thread. Okay, we are locking the thread. So, thread synchronization here is a operation where we are locking our one thread, and then we are in this particular process, we have 3 threads, 3 techniques: lock, using R-lock, using semaphores. Okay, for example, in this we are executing the lock. Okay, lock means deadlock. We have one thread. Okay, here what we are doing is, let's say we have one thread. Okay, thread number 1. When one thread is completed, then we are running the second thread. And when second thread is completed, then we are running the third thread. That is a solution here. We are locking the one thread. When one thread is in use, okay, then we can run the another thread. Okay, for example, you can see here the code is same, but this line is added here. This line here, we are locking this particular L here. L is a variable here, and there's a lock here. We are locking the resources of the class. And once, let's say we have thread number 1. Thread number 1 is taking the resources of class number 1. So whenever one thread is taking the resources of class number 1, what are resources here? This function is a resource here. So when one thread is taking the resources of the class, then other threads are blocked here. And when one thread is executed completely, then we are running the second thread. Then second thread will lock the resources of the first class. Okay, class. Then third thread will not execute without executing the second thread. So it is like, let's say we have this thread here. Okay, we have this resources here. When one thread is running, one thread, we have the second thread, and we have the third thread. Okay, with this third thread. Let's say one thread is taking the resources from my class. Okay, so now in that case, the second thread and the third thread will not able to take the resources of my class, because first thread is using the resources. And when one thread is executed completely, the second thread can use the resources of the class. Now the second thread is using the resources. No other thread can use the resources of the class. And then when the second thread is completed, the third class will use the resources of the my class. Now the third thread will use the resources, and at that time, no one can use the resources of my class. Because what was happening here in the before all the threads are running simultaneously, and all the threads are taking the resources of the class simultaneously. So all the threads are running all together. Okay, because how the threads are running with the help of the class. This is my class. So if one thread is taking the class, like using the class, no other thread can use that class. So this is like locking the threads. Okay, so for example, here you can see we are creating a lock function here. And here you can see this class is locked here now. This particular class is locked. This function is locked here. When someone wanted to acquire the resources, here we will use the acquire function. Okay, acquire. And one thread is acquiring the resources. We have to release the resources. Then here we are using release here. Means inside this function, we have all the resources. This is my resources. This resource is inside the acquire and release here. In the middle of the acquire and release. So what we are actually doing, we are actually calling a reserve function. Inside reserve, we are reserving the resources one time, and then we are releasing it. Then we are acquiring another time, and then we are releasing it. And then when we are acquiring again, and then we are releasing it. Acquiring means we are in use. The class is in use. Release is like the class is not, we are releasing the class so that any other thread can use that class. So that is releasing. First, we are locking the thread. Once the thread is locked, then no one can use the thread. Sorry, when the class is locked, no one can use that class. So for acquiring the class, we are calling the acquire function. By calling the acquire function, the resources are in use. And when the resources are in use by the thread number one, no thread can use the resources. So when the one thread is completed execution, the thread one needs to release the resources. So we are using release here so that other threads can use the resources. So that is acquire and release here. So in the middle of the acquire and release, we have this function here. Okay. And then again, the same function we are running. Now you will see there is a sequence. If I run this one, you can see there is a sequence because two seats are available. One seat is taken by user number one. Second seat is taken by user number second, and zero seat is available. So we have this message here. Sorry, all seats are allocated. And then we are running this main thread. Okay. This is not important here. This is not important here. Okay. So this is in sequence. But what is the problem here? In this one particular thing, we have a problem here. What is the problem? The problem is known as deadlock. Deadlock is a problem when we are saying first you and no first you. For example, let's say there's a resources here. Okay, this is my class here. Now this class, and now we have three threads, thread number one, thread number two, and thread number three. Now, whenever we are locking the scenario, we are locking the situation here, we lock in the class here. Now, these threads will say to each other, no, you can go first. Thread 1 will say to thread number 2 and 3, you can go first. Thread number 2 will say to thread number 1 and 3, you can go first. So this is a condition of a deadlock. When each and every thread are saying to each other, no, you can go first, no, you can go first. No, you can go first, no, you can go first. It is like every thread is saying to each other, you can go first. No, you can go first. So this is a scenario for deadlock. So when this scenario is arising, there will be a time when no one is executing. So because everyone is stuck in saying, no, you can go first. No, you can go first. So that is a deadlock condition. When the classes are saying with threads are saying with each other, you can go first. In that scenario, if no one is going first, which means they are all stuck. They are all stuck in one scenario, which is you can go first, you can go first. So that is a scenario of a deadlock. Okay, so how we can overcome with this deadlock? So the solution is we can use R lock. Okay, we can use R lock here. Solution of a race condition and solution of, sorry, not solution of a deadlock. See, this is a solution of a race condition, but not a solution of a deadlock. See, in this program, if I run this program, see, if I run this one, this is a solution of a race condition and deadlock condition as well. Both. Okay. So how? See, in this R lock, what we are doing, this is a condition of a race condition, like solution of a race condition and solution of a deadlock. So what we are doing here is we are changing one line only, which is this line. In place of L lock, here we are using R lock. That's it. And everything is same here. Everything is same here. What we are doing is how it is overcoming with the deadlock condition. We can know, okay, it is overcoming with the race condition because here we are using lock here. Lock and we're using acquire here. and release here. That is okay. But how it is overcoming with the deadlock? Because we are using join method here. Join method will ensure that first one thread will complete, then we are running the other thread. So that is a join here. While using join here, we are ensuring the deadlock condition here, that no deadlock condition will arise. Why? Because you can notice here, we have this function here, the same function. The only difference is we are using R here, R lock here. Then everything is same here. Here you can notice we are creating three threads. And the three threads we are creating, we are starting the thread. After starting the thread, we are also telling the threads that which thread will come first, then which thread, and then which thread. So we are actually telling the threads that which thread can run first, then which thread can run second, and so on. So here you can notice we are running first thread, then second thread, and then third thread. We are starting the thread. Starting the thread is different than running the thread. We are starting the thread all together. But when we are using join, join will say, join will run the first thread, then join will run the second thread, and then join will run the third thread. So that is a process. So by implementing the join, we are ensuring that no deadlock condition will arise because we are telling the program that first you have to run the thread number one, then thread number second, and then thread number three. There should be a sequence. And we are also ensuring that no thread will say you can go first or you can go first. So that is a scenario here. So if I run this one, you will notice the sequence here. No sequence will disrupt here. Okay, there's a sequence here. Okay. So that is a solution of a deadlock. We are using join here. Then second solution is, this is first solution. Second solution is we are using semaphore. Semaphore. Again, it is a solution of a race condition. What is semaphore? See, semaphore is one of the very oldest technique of a synchronization. In the semaphore, we manage an internal count, which is a decremented by each acquired cell, each acquired call and release, and increment by the each release call. So the counter can never go below zero. When acquire finds that it is zero, it will block, waiting until the some other thread call release. Okay, let's say there's a scenario. Okay, let's say there's a process here, and we have one process, one thread, we have second thread, and we have third thread. So what will happen in the race condition? Race condition will run these three threads together. Okay, and the solution is lock condition, like lock. We can lock the threads. When one thread is running, no threads can run at the same time. But what will happen when I wanted to run two threads together? Together, not all three, just two threads. In that case, we can use semaphore. Semaphore is like whenever we are running two threads together or more than two threads together. Because let's say there's a scenario in which the process wanted to run two threads together at the same time, but it doesn't want to run any other threads at the same time. Okay, that is like we can use semaphore here. Because in the lock condition, we are running one thread at a time. In the race condition, we are running all the threads at the same time. But in the semaphore, we are running more than one thread at the same time. Like we can choose like how many threads I wanted to run at the same time. In that case, we can ensure the scenario. Whenever we wanted to run two threads or three threads at the same time, we can use semaphore. Okay, let's say we have five process here. Now, from the five process, I wanted to run just two threads at the same time. So I can run these two threads simultaneously at the same time with the help of semaphore here. In the semaphore, we are using the increment and decrement condition. Okay, like increment is like when someone is acquiring the resources. Okay, then we can decrement the resources by one. Okay, for example, let's say we have thread number one. If thread number one is taking the resources, if thread number one is taking the resources, then the value of the acquire will become zero. Why? Because someone is taking the resources, and the release condition is become one because someone wanted to release. See, if some thread is taking the resources, it will release the resource and at any given particular point of time. So if someone is acquiring the resources, so it will release also. Okay, so what is happening here is if T1 is taking the resources, then the acquire will become zero because someone is using the resources. Okay, and it will never go below zero. And it releases one because thread one need to release the resources. When thread number one release the resources, the acquire number will become one again and release will become zero because now the resources is available to use and the release is zero here. Why? Because the resources are not allocated yet. If let's say thread number two wanted to use the resources, then the acquire will become zero again because now the resources are in use and release will become one because thread number second wanted to release the thread later on. And when the thread number two release the resources, then release will become zero and acquire will become one because now the resources are available for the acquire. Okay, that is a method here in the semaphore. We are using a release method, a acquire method, and a increment and decrement method here. Okay, for example, you can notice here you have this flight condition here in the flight. We have this seats available. Then we have the semaphore. Semaphore means two here. Means two threads can take the resources all together. Okay. Then here everything is same here. Everything is same. We have this really acquire here, the code here, and the release here. In this case, two functions can run together. Okay, that's it. So you can see available seed 2. Okay, you can see the semaphore here is value is 2 here. Now available seed 1, which is allocated by Aryan, and no seeds are available. In that case, we can run two programs all together, two threads together. So that is a semaphore. Okay, and here we are using increment and decrement here. Incrementation and decrementation is inside the semaphore only. We don't need to put increment and decrement by ourselves. It is implemented in the semaphore only. So in place of rlock, you can use semaphore. So it's your choice. Okay, so I can sum up here. If you are using single tasking is like whenever we are running one thread at a time. One thread one program at a time, one process at a time. So that is single tasking. Multitasking is like whenever you are running multiple process at a same time. Same as multitasking in the threads are like whenever we are running multiple threads at the same time. That is multitasking. But there's a problem in the multitasking that will arise race condition. Race condition is like whenever there's no sequence in the flow of the data when all the threads are running all together. So that is multitasking problem. That is known as race condition. So to overcome race condition, we can use thread synchronization. In this thread synchronization, we have three techniques here. Lock, okay, where we are locking the resources, but this will arise deadlock. So the solution here is unlock and semaphore. Okay. So we are using acquire and release method. Is it clear this much?
So teacher, the I think I remember the what it was the two at the same time thread process was it semaphore. So it
Yes,
means
semaphore.
two at a time and then one release.
Yes.
Okay.
Okay. Like here we can say that two threads can run at the same time. Now, then with this thread communication. Thread communication is like when one thread is talking with each other. That is known as thread communication. So in the thread communication, this program is very interesting. See, in this program, we are creating a traffic light. Okay, here you can see we are importing threading, import thread, and then we are importing a time module sleep. So we wanted to sleep our program for few seconds. Here I have created a function here, which is light switch. So when we run this, when we call this function, first this function will sleep for 3 seconds. Then we are starting the function e.start. Okay, event, e means event dot set. We are setting the event. What is set here? See, see, we have the set, not here. Okay. Let's say we are the set. Set means we are actually starting an event that is set here. Then when this event will start, then this will print this line, green light on. Okay, this will print this line. Then the program will sleep for 5 seconds more, and then red light on. And then we are clearing the screen. What is happening here is we are creating a program, a traffic light. So for 5 seconds, we are turning on the green light, and after 5 seconds, we are uh, turning the red light on. Okay. And here you can see we have a traffic here, another function which will wait. Again, E is an event here which will wait, and it will wait for the green light. Okay, it will wait for the green light. And after in this, if the green light is on, then we can run this program. You can go. Okay. And when after 5 seconds, we are running this program, red light on. So how this program is running, let me run this one. You can see. You will see the flow of program first. Green light, this is not in sequence. Let me new line. Let me run here. First, this will have green light on. Okay. Green light on, you can go, you can go, you can go, you can go for 5 seconds. So this will keep on printing for 5 seconds, you can go. After this one, you can see red light on and program done. So when the light is on, we are printing this message. You can go. But when the light is off, like when the red light is off, we can say no one can go. Okay, because the traffic light is red color. No one can go. And when the red light is on, we are programming. My program is done here. So what is happening here is first we are creating a as a event here. This is like when one thread is communicating with the other. Like how the one thread know that other light is green or red. So this is a case when one thread is communicating with the other. For example, here E is an event here. This is an event here. In this event, then we have these two threads here. Threads are simple, like we have this function here, and the second function is traffic here. And then we are starting the function. So what is happening with the help of this event? We are talking, one function is talking with the other function. How? See, when first this function will run. Okay, this function will run because this is T number one, thread number one. So in this function, we have this sleep equal 3. So first it will sleep for 3 minutes, sorry, 3 seconds. Then here we are setting this variable. E means set means we are first running this line, which is green light on. This will run for 5 seconds. Why? Because here we are sleeping for 5 seconds. After 5 seconds, this line will be printed. So this program will run for 5 seconds. Light will be on for 5 seconds. And then we're clearing the screen. So now this is my one program. Simple function. Now traffic. Traffic is communicating with the light switch. Why? E dot wait. This traffic will first wait for the E, which is this function. So first this will wait for this function, light switch. When light switch will execute, which is this line will execute like green light on, then it will check for the condition that if this light is on, if this particular variable E dot set is set, like if this particular value is set, then we can print the statement you can go. And you can go will print it many times until 5 seconds within this one, 5 seconds. Then we are sleeping for dot 5 seconds, like you can go will print dot 5 seconds. Like after dot 5 second, you can go will print, then you can go will print each out of dot 5 seconds. Then after all program is done. Means this particular function is communicating with this function. When this particular variable is set, we are using while condition. When this particular variable is set, means light is on, then we can run this program. Otherwise, when this particular thing is off, when the light is red light is on, then we are running this program done. So how this function knows that this light is on or off? With the help of E here. E is an event here. So here we are running this condition. If the condition is set, if the green light is on, then we are running this line. And if the green light is off, then we can run print red light on, and then we're printing program done. So when you see here, if I run this program, you will notice first green light is on. Then you can go for 5 seconds. This will run for 5 seconds. After this one, red light on and program done. So you can see each function. These functions are communicating with each other. Okay, communicating with each other. So that is a kind of a thread communication, when one thread can communicate with each other. This concept is not important. It depends on the scenario, but just I wanted to show you. That is why I just run this code. Okay. Then we have this function which is condition object. What is condition object? Condition object is a kind of a scenario we are using. See, let me show you a code here. Okay, first I will run this code, then I will explain the mechanism of the code here. So first I will run this code. Not here. I will run here. So how the code is working, see. First, item produced. One item produced, second item produced, third, fourth, and then five. So there's a company, let's say there's a manufacturing firm, and that company is producing the item number 1, 2, 3, 4, 5. And after producing the item, the company is packing the item in a list. This is a list here. So this particular scenario we can achieve with the help of condition object. Condition object is like whenever our threads are running all together, and we are also counting the threads, like how many threads are running, and then we are putting the output of the thread in a simple list. When we are storing the output of the thread in a single in one place. For example, here you can notice that we can achieve with the help of condition object. Here we have a function. Here we have this empty list. Then we have one function which is produce. So first, produce will acquire. CV means condition object. Condition will acquire this function. Okay, this will acquire. So it will acquire. It will run 5 times. Okay, whenever this particular function is running 5 times, then we are keep on appending the number 1, then 2, and then 3, and then 4. We are appending the numbers in the list. Okay, when product will consume, like one product will create, then we are storing the product in the list. Then second time the loop will run, then we are storing the number here. Then third time and fourth time. So and then we are printing item produced, and then we are notifying the CV that the item is produced, all the items are produced, and then we are releasing the items. Okay. In the consume, we are acquiring. Okay, this is thread number second. Here we are acquiring. Once this one is released, then we are acquiring this one, and this will wait for some time. It will wait for this particular function to execute. That is a wait here. Okay, this particular, see, these functions are running together. Okay, these threads, def number, produce and consume, these are running together. Why? Because that T number 1 and T number 2 are running together. We have the starting here. So they are running together. But this is multitasking. But whenever we are performing multitasking, there's a problem of sequence here. So we are avoiding the problem of sequence with the help of acquire here. So when one function is acquiring the when one thread is acquiring the resources, no other thread can acquire the resources. So here you can see the consumer. This consumer will wait for wait for this function to complete, then it will release, then it will run the program. Okay, for example, first we are running this loop 5 times. With each and every loop, we are adding the number in the list. Okay, and we are printing this one item produced. And then after producing all the items, we are notifying this particular function that my work is completed. Now you can do your work. So if the CV is notifying the other function, other thread. It is notifying the other thread that my work is completed. Now you can start your work. So at that time, the thread number 1 will release the process. Now consumer will start acquiring the process, wait for some few seconds, and then release the process resources, and then print the list. Okay. So here, what we are doing? See, we are running the threads all together. There's no sequence here. But why implementing the condition here? We are implementing a sequence here. That first function number 1 will execute, then function number 2 will execute. That is why it is now condition object. It is like a company is manufacturing everything and then putting everything in one place. After manufacturing all the products, then the company is distributing the products in the market. That is a flow. The same example we are using here. The company is first producing everything, then keeping everything in one place in a list. And after everything is produced, then we are distributing the item in the consumer. which is we are printing the list. So if I run this one, you will notice item produced, five items are produced 5 times, and then we are printing the list all together. That is a condition object. So is it clear? This one? Any question?
No, teacher.
Okay. Threading is like a kind of a complex topic. If you run this program again, you will like in your own machine, you will understand. Okay.
Yes,
The
teacher.
last
Yes.
we have queue. Queue again is a concept. First, I will run the code, then I will explain. Okay. So queue is another kind of a data structure. So we are implementing queue in the threads. So if I run this one, you will notice item produced one, then item received one. Item produced second, item received one second. Item produced three, item received third. So you can see these are in sequence. What I said in the queue are like first in, first out. When we are putting one item, then one item will out first. We are putting second item will out first. Last, then. Third item will put first, then third item will out, then. And then fourth item, fifth item, and so on. Same as you can see, first we are putting one item, then one item will out first. Then second item we are putting, second item will out. Then third item, and so on. So it is like first in, first out condition. Here you can see we are importing queue here and threads here. So we are importing a queue mechanism here. We are creating a queue data structure here. So you can see with this class producer, this will take queue as a function, as a class. Okay, queue is a kind of object here. Then with this produce is another function. This will run 5 times. Okay, and you can see whenever we are running the queue is like you can think of a basket here. Queue is like a basket here. Okay, so here we are creating a basket here in this line of code. We are creating a basket. This is my basket here. Then we are producing the item. When we produce one item, then we are putting one item in the basket. Putting one item in the basket, which is q dot put I. I is one item. Then sleep for 1 second. Then after 1 second, we are putting the second item, which is second item here. Then we are putting the third item, then fourth item, and then fifth item like this. This is my queue. This is my queue here. Okay, we are putting. Then how to fetch items from the queue? This is consumer. So we are creating another class, consumer, and this is prod. Prod is a variable here. Then we are taking the item from the queue. So you can see queue dot get I. I is the items here. So now we are getting items one by one. Item number one, item number two, item number three, four, and five. Because in the queue, there's a concept of first in, first out. So you can see which item is first in, item number one. So item number one will first out. Then item number second, item number three, four, and five. Okay, so that is the example of a queue. And here we have this init here. Okay, so we have this P here, P for this producer class here, same as consumer. Here you can see consumer is taking a variable prod. Prod will take a variable of producer. Sorry, consumer will take a parameter of a prod here. P here you can see, which means consumer is taking the resources from producer here. Okay, you can see. Then is T1 and T2, and then we're starting the thread. So whenever I run this one, you will notice item number one first produced, then item number second. Item number second, then item number second. Then item number third will produce, then item number third will receive here, and so on. Okay, and how it is achieving with the help of a queue here. In this consumer is talking with the producer. So consumer will first the produce will run first line, which is item produce one. Then consumer will run its line, which is item received one. Then produce will run second line, item produce second. Then consumer will run second line, which is item received second, and so on. So we are getting and putting the products in the queue, and we are fetching the products from the queue only. So that is a concept of queue, which is first in and first out. Okay, is it clear?
Yes, teacher.
Any question?
No, teacher.
Okay, so we have completed the multi-threading. Now we
Mhm.
are remaining with the one topic only, which is database. Database we will continue in the next week. Okay.
Okay,
And if
teacher.
you are available in the weekdays, then you can also let me know so that I can arrange your class in the weekdays also. Okay, so
Yes,
just
teacher, I
message
will.
me before one day. If you are available, let's say on Monday, Tuesday, Wednesday, or any other day, then you can inform me. Okay.
Yes, teacher.
Otherwise, we will continue on Saturday only.
So maybe I teach next week. So you said one more last class.
Sorry.
So I guess I'm available on yeah, still Friday Saturday for still I'm available.
Okay, Miss Friday, right?
Yes,
Okay, so I will ping you on WhatsApp, like my schedule also. So
yes,
we will
please.
arrange the class on Friday as well. Okay.
Yes.
Okay. Any other questions from the multi-threading? Any doubt?
No, teacher, I will let me practice first and then I will let you know in the message.
Okay. So if you have any question from the multi-threading, please let me know. We will revise that concept again. Okay.
Yes,
So
thank you very much,
rest we
teacher.
will rest we will continue in the next day, next week,
Yes, teacher.
and I will share the recording and this files. Okay, please
Yes,
practice on this file.
yes, I will. Thank you, teacher. Have a good day.
Yeah, you